Now guys, welcome back to another video. So here I'm presenting an example for how to find yield when there is capital gains tax. Let's just check out the next few slides as what I've detailed. So an investor who is liable for capital gains tax may wish to determine the net yield on a particular transaction in which he has purchased a loan at a given price. So basically, this is your typical bond pricing equation. However, there is one possible approach, and this one is probably the best approach, and that is to find the yield using the method of interpolation. Even though this method is not the fastest and the purchase price is known and such, this is still the best way to calculate it, as all you need is an upper and lower bound. And we can easily find that thanks to the capital gains formula. And lastly, in this situation, one may easily write down an equation of value which will provide a simpler basis for interpolation. And I'm going to show you guys in the next example. So let's jump in. So here's the example. So suppose you got a loan of 1,000 bears interest, or not bear, 1,000 bears interest of 6% per annum payable yearly and will be redeemed at par. So this is typical bond pricing. So we're going to use this for the calculation of coupons after 10 years. An investor liable to income tax and capital gains tax at the rates of 40% and 30% respectively. And he decides to buy the loan for £800. Okay, so first thing we can say that we know that the price of the loan immediately is £800. And we know that the loan itself, denoted by X, would be 1,000. The interest, so we know this loan bears interest of 6% itself, correct? And by the way, by the 6%, this is going to be, since redeemed at par, we're going to use this as the coupon pricing. So, and under a coupon situation, it's treated the same way. This would be the rate. So let's treat this as a coupon rate of 6%. That's how it's usually worked out. And we got the time frame, which is 10 years. We also know that taxes, there's a situation of tax involved where we got the income tax and capital gains tax. No problem. But under the situation, the question is, what is his net effective annual yield? This is assuming that capital gains, that there is in fact capital gains if we are trying to find the yield, because there will be capital gains. So under the assumption there is, we can therefore write the equation value. So the equation value in general would be P equals, so 800 equals your standard one, which would be X times the discounted factors to the power 10, so 1,000 times V to the power of 10, 10 years, plus your coupon rate, which is 6% of 1,000, can easily be computed 60. And this is payable yearly for 10 years at a rate of 6%. We also know that there's capital income tax. So income tax is applied to this unit, so it would be 1 minus 40%, so times by 6%. So 60 would actually be down to 36. Nice and easy. So we're doing this as we go, yeah? Next, because of capital gains, we need to subtract the capital gain quantity, which is 30% of the difference between the redemption value and the price of the bond. So 30% of 1,000 minus 800, which will be 200, and this will be discounted by 10 years. Now immediately we can combine this unit and this unit because they are pretty much the same, and they have the same base, which is v to the power 10. So immediately 30% of 200 is 60. So 1,000 take away 60 will give us 940. So therefore our equation of value would be 800 equals 940 v to the power 10 plus 36 times annuity payable annually for 10 years at 6%. And that's it, guys. So this is pretty much where we begin. Now, at this stage, this is where we're going to start calculating our, what's it called again? Our annual effective yield. All right, so let's begin now. Okay. So now, using our equation of value, we need to decide what values of I is respectable. So we need an upper and lower bound to actually interpolate to find the middle value, which is the correct I. So one possible way is to consider the capital gains requirement. So firstly, we know in general the capital gains states that there is capital gains if the yield is greater than the coupon rate, which was 6%, times 1 minus income tax. Income tax, I believe, was 40%. Yep. So 1 minus 40%, so that's 60%. So yeah, simple maths. 6% times 6 is 3. So this is about 3.6%. Yep, 3.6%. Man, I didn't sound confident there. So we know for sure that that this would be the lower bound I, and the effective is for sure greater than this. So therefore I lower bound would be 3.6%. Now, for the other possible intervals, I wrote down in the next slide. So we know that the minimum value for the yield would be 3.6%. So again, this is denoted by IL. We also know that if the net gain on redemption is £140, so remember this 140 is calculated by the difference between the net gain on redemption over the price. So 940 take away 800 would give us 140. And this were paid, if this were paid in 10 equal years, 10 equal installments over 10 years, then we could simply assume that would be £14 per year. So the net each year would be 36, which is the rate after income tax when the coupon is affected. So 60% after income tax plus £14. So that makes £50. And if we did that as a fraction, 50%, 50 over the price of the bond, this is equivalent to 6.25%. And this, my friends, would be the absolute maximum the yield can take. It will never be this, by the way, because due to decreased interest rate. This is just theoretical. So theoretically speaking, this would be the absolute maximum, which we'll never reach. So yeah, so that means we got a bound. So hence the yield is somewhere between these two values. Now, how does the method interpolation work? Well, on the next slide, I presented the formula, which it was quite hard to summarize actually, but I came to this conclusion. So using the general xy, so I let in this case x be the I and y be the function. So the yield I is equal to, so this is the true yield, is equal to the lower bound yield, which was okay, it's not 6.25%, it's actually what was it, 3.6%. Don't worry, the answer is correct. I double checked it, guys. And the function is plus the difference between the function I and the lower and minus the lower bound rate in that equation of values. Oh yeah, so the function itself, we need to define that. The function of I is actually given by the equation of value when I set it to 0. So when you set it to 0, this equation is 0. So this will give us a figure. So using the original equation, it's going to be 940 times v to the power 10 plus 36. So if you remember, something like this. And to make it 0, we need to subtract both sides by 800. So yeah, so this is our equation we'll be using. And we know that this is set to 0, because if this is 0, that means whatever value for I needs to be a certain value for this equation to be 0, and then we have our yield. And times in the difference between the up and lower, which is 2.65%, and the difference between up and lower functions once you plug in the i's. Alright, so let's start calculating, guys, yeah? So I did it already. So when I equals the lower bound, you get 3.6%. Plug into the discount formula, so v equals 1 over 1 plus I. Replace with IL, you get this figure, 250 over 259. Again, for the annuity, do the same thing. Use the general formula, which is 1 minus v to the power n, or 10 over I. Plug in your VL and your IL, and you get 8.2748. And then plug it into the function formula, so the equation of value. Write the whole thing, replace the V10 with this 250 over 259 power 10, and same A10. Plug in, you get 157.872. And next up, do the same for the upper bound. Repeat the same method as illustrated, and you should get a negative answer for the function, which is actually good, by the way, because you need negative, otherwise this formula will mess up. Because remember, this becomes negative, 0 minus this low I lower bound, which is positive, so it'll be minus 157, and times against the ratio, so subtract the raise over the subtraction of this, and you should get that. And finally, yeah, let me take a breather. And yeah, finally, so sorry about that, I can record every 5 minutes, so I keep stopping after the 5th minute. So yeah, so now plugging in this into the formula, so make sure you get 3.6% plus the difference between the functions should be negative 157, 0 and that. Difference between the yield should be this, and difference between functions should be negative. So these two negatives become a positive. So this would be a small increase over the low bound. And finally, the yield is approximately 5.88%. Voila, and that is between the two bounds. So yeah, this I believe is the legit answer. I double checked it and it took a long time. So hopefully this helps, and let me know if you guys got any other questions, yeah? Other than that, I shall see you all soon. Ciao.